Okay, so in this video you will see some examples of change of phase calculation problems. I have written down the formulas that you need. Q equals mc delta T, which the formula that is used to find the amount of energy needed to change the temperature of a substance without changing its phase. And this one, the second one, is Q equals ml to find the amount of energy needed to change the phase of a substance without changing its temperature. So these all problems here are very basic one. So, and I think that you can easily understand the explanation of these examples. Okay, I will use the black ink here. Okay, and the first problem here is calculate the amount of heat required to change the phase of 2 kilogram ice to 2 kilogram liquid water at 0 Celsius degree. So basically this is just a change of phase of ice to liquid without changing its temperature. So you only need this formula, Q equals ml. And then we know that the latent heat of fusion of water from ice to liquid is 80 calories per gram. This is the latent heat unit is in calories per gram. So you need to change the kilogram into gram first, which is 2000 grams. And then the latent heat is 80 calories per gram. And then you will get 160,000 calories by cancelling the gram here and the gram there. Okay, so this is the final answer of number 1. We'll continue to number 2. See number 1. How much energy do you need instead if you want to have 50% liquid water and 50% ice? When you change the phase from 2 kilogram ice to 2 kilogram liquid water. So basically you will have you require half of the energy, and you can basically just multiply this much of energy by half. Half times the 2000 gram times the 80 calories per gram. Cancel the grams, and then you will get 80,000 calories. You will have 50% liquid water and 50% ice. That's it for number 2. Next is number 3. If you give 1000 calories to the 2 kilogram liquid water at number 1, this one, how much is the final temperature? Now this one requires the first formula, which is to find the energy required for the substance to change its temperature. And this 2 kilogram liquid water, it will just remains in the same phase, which is liquid. And this is how we are going to solve this. Q equals mc delta T. M here is 2000 gram, and C, which is specific heat capacity of the liquid water, is 1 calorie per gram Celsius degree. 1 calorie per gram Celsius degree. Multiply by the delta T. By knowing the delta T, you can know how much is the final temperature from 0 Celsius degree as the initial temperature. Here you write 1000 calories. Then you will multiply this. 1000 calories becomes 2000 calorie per Celsius degree times delta T. And then you divide 2000 on both sides and you will get 1000 calories per 2000 calories per Celsius degree equals to delta T. For the delta T, you will get half Celsius degree. And this is not the final answer because delta T is just the change in temperature, so you need to find the final temperature. We know that delta T is Tf, which is the final temperature, minus the Ti, which is the initial temperature. So half Celsius degree equals Tf minus Ti, which is 0 Celsius degree from number 1. And then so we will get Tf equals half Celsius degree. And that's it for number 3. The last one is number 4. How much energy is released when a 2 kilogram water vapor changes to 2 kilogram liquid water? So this is a change from higher energy level to lower energy level. The same process of calculation works for changing from low to high energy level also. So you basically just use the same way in order to find the final result. And if you see the question, this is only changing phase. There's no information about the temperature, so it means that the temperature stays the same. There's only change of phase happening here. So the formula that we use is the Q equals ml. Q equals ml. And then we know that the L, the latent heat of vaporization, is 540 calories per gram. Okay. We write down here 2 kilogram. We need to change it into gram so that it is consistent with the latent heat unit. 2000 gram multiplied by 540 calories per gram. Cancel this gram, and then you will get 1, 2, 3, 4. 2 multiplied by 54 is 108. You will get 1,080,000 calories. And so these 4 examples of change of phase calculation problems, I hope that it will help you in understand more about change of phase calculation. Thank you.